Welcome to Hired in AT. Our mission is simple: help you build the skills that employers actually want. Whether you're trying to land your first IT job, switch careers, earn a promotion, or increase your salary, we're here to help. Every video is thoroughly researched and designed to make complex IT topics easy to understand. If there's an IT topic you'd like us to cover, leave a comment below. We may turn your suggestion into our next video. Turning IT knowledge into career opportunities. Your brand new $2,000 gaming rig just choked opening a second browser tab. The CPU is a 12-core beast. The GPU cost more than your first car, and yet the whole system feels like it's wading through molasses. You pop the side panel, and there it is. A lone 4 GB stick of RAM. Random access memory, your PC's short-term memory, in a motherboard with 4 empty slots. Welcome to Part 3 of the IT Fundamentals Masterclass, where we expose the silent performance killer that can turn a dream build into a slideshow. By the end of this video, you'll have a RAM playbook that saves you from that exact nightmare. First, you'll know exactly what RAM does and why it's your PC's short-term memory. Second, you'll decode specs like DDR, double data rate, generation, speed in megatransfers per second, and CAS latency, so you can make a bulletproof buying decision. And third, you'll fix the #1 mistake that strangles performance: running single channel or forgetting to enable XMP, Extreme Memory Profile, which ensures your RAM runs at its rated performance profile. Think of your computer like you at a desk. The filing cabinet across the room is your SSD or hard drive, big and slow. RAM is the desk itself. Whatever you're working on right now, you spread out on the desk so you don't have to walk over every time you need a scrap of paper. Even a fast storage drive is orders of magnitude slower than RAM, so the less you walk, the faster you finish. The CPU is your brain. If the desk is too small, you spend more time walking than thinking. Back in the early 90s, loading a single program meant waiting for a floppy drive to grind away for 10 seconds, then another 10 for each save. The CPU sat idle, drumming its digital fingers because storage was just too slow. RAM was the fix. An ultra-fast electronic buffer that holds the bits you actually need right now. The catch? It forgets everything the moment power cuts, and it's expensive compared to a spinning disk. That's why we still have both storage and RAM. Your desk goes blank when the office power goes out. That green stick you slot into the motherboard is a grid of billions of tiny cells. Each black chip is a dynamic RAM chip, and inside each chip, the basic unit is 1 transistor and 1 capacitor. The capacitor holds a charge, charged for a 1, discharged for a 0. The transistor acts as a gatekeeper, letting the controller read or rewrite that charge. Billions of these pairs, refreshed thousands of times per second because the charge leaks away. That's it. That's the engine behind every running program. Time for a quick recall. You just saw how a DRAM cell works. Pause the video if you need a moment. What 2 components make up a single DRAM cell, and why does it need constant refreshing? Every memory cell in the sticks you install is a transistor-capacitor pair. The capacitor leaks, so the cell refreshes constantly to keep its value. If you got that, you already understand the heart of system memory. DIMM, Dual Inline Memory Module, is the technical name for a RAM stick. But the memory stick you install in your laptop is made of a specific type of RAM, DRAM. That's dynamic RAM, which uses a transistor and capacitor per cell to store data. The other type, SRAM, or static RAM, is much faster but far more expensive. It's used inside the CPU as cache memory, not as main memory. So no, your RAM stick is not the same technology as CPU cache. DRAM gives you capacity at a reasonable price. SRAM gives you speed where it counts. RAM technology has evolved through several generations: DDR, DDR2, DDR3, DDR4, and the latest generations continue to push bandwidth higher. Each new generation increases bandwidth significantly while consuming less power, but exact numbers depend on the specific kit. The physical connector design also changes between generations, so you cannot accidentally mix them. Always check your motherboard's supported memory type before buying. You've seen numbers like 3200 on the box, which indicates the data rate in megatransfers per second, the speed at which data is moved. Think of it like a metronome ticking billions of times per second, moving a tiny packet of data each tick. Now, the most common trap: if you mix memory sticks with different speeds, they may all run at the speed of the slowest one. You could pay for speed you never get. That's because the memory controller defaults to the lowest common denominator for stability. Always install matched sticks with identical speed and timings. Two kits both labeled 3200, but the 4-digit number after CL, CAS latency, tells the hidden story. CL16 needs fewer clock cycles to deliver data than CL22. That means lower latency, which can translate to snappier performance in memory-sensitive workloads, like gaming. And the price premium for lower latency kits is often minimal. So when comparing RAM, don't ignore the CL number. Your friend's older DDR4 machine might feel snappier than your brand new DDR5 build. How? Latency. While DDR5 delivers higher raw bandwidth, its timings are often looser. The true latency depends on both speed and KS latency, and sometimes the older kit ends up quicker for certain tasks. For workloads that bounce between lots of small data chunks, like compiling code or launching apps, lower latency can make a machine feel more agile. Before you chase the newest generation, compare the actual latency ratings. Sometimes the older tech is actually quicker where it counts. Quick recall. You just learned that CS latency can strangle performance even with lots of gigabytes. So, true or false, a 32 gig kit with KS22 will always outperform a lean 16 gig kit with KS18. Pause and think. Let's check your RAM speed the practical way. Open Task Manager. Right-click the taskbar and select it, or press Ctrl-Shift-WASC. Click the Performance tab, then Memory. You'll see a field labeled Speed. If it shows 1800 memories and you have DDR4 3600, don't panic. DDR memory transfers data twice per clock tick, so the effective speed is double the base clock, 3600 MHz. That's exactly what you paid for, and your RAM is running at full speed. Need more information than Task Manager provides? Open PowerShell and run the following command. Get sim instance. Win32. Physical memory. Select object. Bank label, capacity, speed, manufacturer, part number. This command displays every installed memory module in your computer. Bank label shows which motherboard slot the RAM is installed in. Capacity tells you how much memory each stick contains. Speed shows its rated operating speed. Manufacturer identifies who made the module, and part number gives you the exact model. That part number is especially valuable when upgrading your system because buying an identical memory module helps maximize compatibility and stability. If you discover your computer has one 8 GB stick installed, you can often add a matching 8 GB stick to enable dual-channel memory and improve performance. Learning simple PowerShell commands like this is an important IT skill. Instead of opening the computer case, you can quickly inventory hardware from the command line, something system administrators do every day. To wrap up the latency discussion, a quick check. If you see two kits both rated 3200 MHz, but one is CL18 and the other CL22, which will generally have lower true latency? Yes, the CL18 kit. Lower CL means fewer clock cycles and therefore shorter delay. So when comparing similar speed memory, the smaller CL number wins. Dual-channel memory is the closest thing to free performance you'll ever find. Instead of one 64-bit pipe between your CPU and a single RAM stick, dual-channel splits the load across two identical sticks, creating a combined 128-bit data path. That effectively doubles your memory bandwidth without overclocking or spending an extra dime. The catch? The sticks must be installed in the correct paired slots. Motherboards often color-code these pairs. Check your manual to see exactly which slots to use. If you install two sticks right next to each other on the same channel, you're stuck in single-channel mode, leaving half your potential bandwidth on the table. For a gaming PC or any throughput-hungry task, that's the difference between smooth frames and stuttery regret. Quick pop quiz. You're choosing between two DDR4 kits, a 3200 MHz CL22 kit and a 3600 MHz CL18 kit. Which one actually responds faster and why? Pause if you need a moment. The 3600 CL18 kit combines a higher clock with a tighter keys latency, so it responds faster than the 3200 CL22 kit, despite having a lower first number. That CL value is the hidden spec that determines real-world snappiness. Beginners often confuse RAM with ROM, so let's settle it. RAM is volatile. Everything vanishes the instant you cut power, like a whiteboard wiped clean. It's where your operating system and apps live while they run. ROM, on the other hand, is non-volatile and read-only under normal operation, more like a printed manual glued inside your case. It stores the firmware that tells your motherboard how to even start up. You can't save files to RAM, and you'd break things if you could. They serve completely opposite purposes, one for speed and temporality, the other for permanence and instructions. Understanding this distinction is one of those foundational IT literacy checkpoints that keeps you from making silly mistakes on the job. To appreciate why RAM matters, picture the entire storage hierarchy. At the top sits the CPU cache, which responds in billionths of a second. Next comes system RAM, where your active programs live while they're running. Below that are SSDs, which are dramatically slower than RAM, but far faster than traditional hard drives. Finally, mechanical hard drives provide the largest capacity but the slowest access times. Each layer serves a different purpose. CPU cache keeps the processor busy. RAM provides fast workspace for active applications. SSDs permanently store your operating system and programs with quick access times. Hard drives offer economical storage for large files and backups. Understanding this hierarchy explains why modern computers combine all four technologies instead of relying on just one. Why does a 16-gig DDR4 kit swing so much in price? It's not random. DRAM prices are driven by supply and demand, new manufacturing process transitions, and global events. Before you buy, check current prices on PC Part Picker or Camel. The best RAM deal is the one you get at the bottom of the wave. Quick checkpoint. You install two identical RAM sticks in the correct slots. What real-world benefit does dual-channel mode deliver, and which of these two speeds is faster? DDR4 3200 or DDR4 26666? Pause if you need a moment. Under the hood, RAM comes in two radically different flavors. On the left, DRAM, what you buy on a stick. It is cheap, dense, but its capacitors need refreshing. On the right, SRAM, the high-speed cache built into your CPU. It uses far more transistors per bit, no refresh needed, lightning fast but expensive, and takes up more chip space. That is why typical CPU caches are measured in megabytes, not gigabytes. This split is why your system can have 32 gigs of DRAM, yet only a few dozen megabytes of SRAM cache, and still fly. One more recall. Your PC's CPU cache uses one type of RAM, and the removable sticks in your motherboard use another. Which is which, and why? Let's lock in the 3 commandments. 1. RAM is your system's short-term workbench. If it's too small or too slow, even the fastest CPU starves. 2. Generation, frequency, and KAS latency together define how snappy your PC feels, not just the gigabyte number on the box. 3. Avoid self-inflicted bottlenecks. Populate the correct slots for dual-channel, enable XMP for Intel or DOCP, AMD's direct overclock profile, their version of XMP, in BIOS, and run the Windows Memory Diagnostic tool at the first sign of trouble. Tonight, open Task Manager and verify your RAM speed. Then run the Windows Memory Diagnostic tool just to know your hardware is solid. Now that your RAM knowledge is bulletproof, one crucial reminder before we move on. If you bought a fast RAM kit, enable XMP or DOCP in your BIOS. Otherwise, your system runs at default GDEC speeds. That's the standard safe speed specification, wasting that speed you paid for. Now, it's time to answer the storage question everyone asks. Is the old spinning hard drive finally dead? Part 4 of the IT Fundamentals. Masterclass pits SSD against HDD with real-world boot times, durability truths, and the one data recovery fact that still keeps hard drives alive. Subscribe and ring that bell so you don't miss it. See you there. Remember, careers aren't built by watching videos. They're built by applying what you learn. Pick one thing from today's lesson, build it, document it, and share it. That's how you get hired. Thanks for watching Hired in IT, where we're turning IT knowledge into career opportunities.